Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungri, MSc MPhil Mathematics, your math tutor from C.D. King Higher Secondary School, Science Stream, Jotsama, Kohima. In the last session, we learned how to find the derivative of composite functions using chain rule, and in this session, we are going to learn how to differentiate implicit functions. First of all, let us learn what is an implicit function. See, let me take a function like x plus y minus 1 is equal to 0. Can we write this one as y equal to fx form? Yes, possible, right? So we keep y here and bring the other two other side. So 1 minus x. See here, y is written as like this. X all one side and y another side. So we can separate the variables, isn't it? So this is called explicit functions. If we can write y in terms of x easily, that is called explicit functions. Okay, what do you mean by implicit functions? For example, x square minus sine xy plus y square is equal to 0. So we do anyway, we cannot separate this x and y, not easily, isn't it? So here we say that this function is implicit function. Implicit functions. So how to derive this, differentiate this implicit function? We have to just differentiate both sides of the equation, okay, term wise. Then it will give you the derivative of implicit functions. Okay, this is how we are going to do this derivative differentiation of implicit functions. Let's start with the exercise 5.3 in your textbook. Here 2x plus 3y equal to sine y. It is clearly an implicit function, right? So it is an implicit function. Okay. Then we will differentiate this with respect to x. We get differentiation of 2x. Differentiation of 2x is 2, right? Plus 3y. 3 is a constant multiplied with y. Y is a dependent variable. When you are differentiating y with respect to x, you will get y dash or dy by dx. So 3 into dy by dx. When you differentiate x with respect to x, you get 1. But when you differentiate y with respect to x, you will get dy by dx or y dash. So that is equal to. Then when you differentiate sine y, what is the derivative of sine? Cos, isn't it? So cos y, then there is a variable here, y, dependent variable. If you differentiate y, what do you get? Dy by dx. Okay, then collect dy by dx one side, that is 3 dy by dx minus cos y dy by dx is equal to minus 2. This gives us 3 minus cos y dy by dx equal to minus 2. Then take this 3 minus cos y other side, that is dy by dx equal to minus 2 by 3 minus cos y, or you can write it as 2 by cos y minus 3. That's all. The second problem is xy plus y square equal to tan x plus y. This is also an implicit function. So if you differentiate this equation with respect to x, we just differentiate both sides of the equation term wise. xy, see, you have to be very careful here. xy, this is a product of two variables, isn't it? So we have to go with the product rule. Product rule is, once again let me write here, d by u, this is better to remember, uv whole dash will be uv dash plus vu dash, isn't it? So here product of two variables, so we are going with this formula, product rule. Here in place of u, you have x, and in place of v, we have y. So I am going to do it directly here. Okay, so here it will give us uv dash, x is u. So x, if you differentiate y, what you get? Dy by dx. Plus, in the next term, you keep y constant and differentiate x. So if you differentiate x, you will get 1. Right. In exams, you will not get time to write everything in the side of the page and find out the derivative and write it back. So if you learn how to do it directly, that will be saving you much of your time. So keep x constant and differentiate y, plus keep y constant and differentiate x. Okay. Then plus y square. How do you differentiate y square? So put the power in front and then reduce the power by 1. So it will be 2y1. Is it done? No, it is not, because here it is y. So we are differentiating with respect to x. So when you differentiate y with respect to x, you get dy by dx. Here we have differentiated only the power, not y. When you differentiate the y, you will get dy by dx. So that is equal to, then the other side of the equation we have tan x plus y. So what is the derivative of tan x? Derivative of tan x is secant square x. So secant square x plus differentiation of y is dy by dx. Okay, now let us collect the dy by dx terms one side. So x dy by dx plus 2y dy by dx minus dy by dx equal to secant square x minus y. So if you take y dy by dx other side outside, then x plus 2y minus 1 into dy by dx is equal to secant square x minus y. If you take this one other side, you get dy by dx equal to secant square x minus y by x plus 2y minus 1. So this is the answer. So clearly it is an implicit function. So we will differentiate the equation either side of the equal. So differentiate with respect to x. We get, please write this line with respect to x, with which variable you are differentiate, that should be written. Then if you differentiate sine square y, I already told you this is a composite function, that is square is there. The square is holding this sine y. First let us differentiate this square. So it becomes 2 sine y whole to the power 1, you don't need to write, into, then you differentiate this sine y. Sine y differentiation is cos y into y differentiation is dy by dx. First let us differentiate the power, then we will go inside and differentiate this sine, and then we differentiate y. Plus here cos xy, this is also a composite function because this cos is holding this xy. First let us differentiate this cos. So differentiation of cos is, the derivative of cos is minus sin x. So it becomes minus sin xy. Minus sin xy. Then we will go inside and differentiate this xy. Again here, if you look at this carefully, it is a product of two variables. So we have to go with that product rule. Product rule is uv whole dash is equal to uv dash plus vu dash. So it is x constant into differentiate y, that is dy by dx, plus keep y constant and differentiate x. So you get 1. That is equal to, it's k, right? No, it is not k. The k is a constant. So derivative of constant is 0. So we missed to notice this. So we keep bringing this k till the last step. Then you will get 0 for this answer. So here 2 sin y cos y dy by dx, plus of minus is minus. Then at the same time I multiply this inside. Okay, so minus, I'll put this x in front of it to avoid confusion. If you write x, y, x, it is wrong. Okay, so you write this x in front of it. X sin xy dy by dx, and again minus into plus minus y sin xy equal to 0. Okay, then this is an identity which we have studied in class 11, that is 2 sin y cos y is equal to sin 2y. Sin 2y dy by dx minus x sin xy dy by dx minus y sine xy equal to 0. So if you take dy by dx outside from the first two terms, then what you get? Sine 2y minus x sine xy is equal to y sine xy. So which gives us dy by dx equal to y sine xy whole divided by sine 2y minus x sine xy. So that's all. This is the answer. So now you can do how to you can do the derivatives of implicit functions. Let's move on to the next one, derivatives of inverse trigonometric functions. Okay, let us find the derivative of sine inverse of x. So y equal to sine inverse of x. Let us take y as sine inverse of x. We are going to find the derivative of sine inverse of x. So if this is case, then we can write this one as x equal to sine y, which we have already studied in chapter 2. Alright, then now you differentiate this with respect to x. So what do we get? 1 equal to cos y into dy by dx. Yes or no? Sine derivative is cos, and then you differentiate y, you get dy by dx. So this will be 1 by cos y, that is equal to dy by dx. Okay, so let me write this one other side, just interchanging the terms. So 1 by cos y. So we have studied earlier, that is cos theta can be written as root over 1 minus sine square theta, right? So using that identity, sine square theta plus cos square theta equal to 1. So root over 1 minus sine square y. So that is equal to root over 1 minus sine y is x. So sine square y will be x square. Therefore, the derivative of sine inverse of x will be equal to 1 by root over 1 minus x squared for every x belongs to open interval minus 1 comma 1. If you take minus 1 and 1, it will become 0. Denominator should not be 0, right? That's why we are excluding this minus 1 and 1. And also, if you give more than 1 or less than minus 1, it will become negative. Okay, so inside the square root, if it becomes negative, it won't be a real number, it will become a complex number, isn't it? Imaginary part. Therefore, we are not taking the other real numbers, only in between this minus 1 and 1. This is the domain of the derivative. Okay, when the x is in this interval only, we can find the derivative of 1 by root over 1 minus x square. So similarly, we can write the other derivatives. Cos inverse of x is minus 1 by root over 1 minus x square. Then d by dx of tan inverse of x, that is 1 by 1 plus x square. Here we can take all the real numbers for x. This is same interval, alright. And then d by dx of cot inverse of x will be minus 1 by 1 plus x square. This is also for every x belongs to R. So here are the derivatives of inverse trigonometric functions. In addition to this list, you have to add all these 6 more. So derivative of sine inverse of x is 1 by root over 1 minus x square. The domain is open interval of minus 1 comma 1. Similarly, cos inverse of x, only the minus you have to put in front of it. And tan inverse of x will be 1 by 1 plus x square. And cot inverse of x will be, you have to put minus in front of it. And the secant inverse of x is 1 by absolute value of x into root over x square minus 1, where the domain is r minus closed interval of minus 1 comma 1. That is excluding this interval. You can take any other values of x. And then cosecant inverse of x will be minus 1 by absolute value of x into root over x squared minus 1. So please write down this one in your notebook very clearly and memorize it. That is very helpful for you to do the differentiation quickly. Okay, let me show you only one problem from this question by substituting the trigonometric identity. This type of problems, we have to do some trigonometric substitution. Then it is easy for us to find the derivative. Okay, sine inverse holds this 2x by 1 plus x square. Let us simplify this one. So putting x equal to tan theta. So this implies theta equal to tan inverse of x, right? Okay. So you substitute here y equal to sine inverse of 2 tan theta by 1 plus tan square theta. Hope you remember this identity which you have studied in class 11. This is equal to sine 2 theta. So this gives us sine inverse of sine 2 theta. This also we have studied in our inverse trigonometric functions. That is sine inverse of sine theta can be written as 2 theta. Yes or no? Then theta can be replaced with tan inverse of x. 2 times tan inverse of x. Still we did not start the differentiation. We are just simplifying the given question. Okay, now only we are going to differentiate it. So differentiating with respect to x, we get dy by dx equal to 2 is a constant, so it will be same as it is. Since it is in multiplication of tan inverse of x, then if you can remember the derivative of tan inverse of x, that is 1 by 1 plus x square. So it gives us dy by dx equal to 2 by 1 plus x square. This is the answer. Here also we are going to do substitution. If you look at this form also, you should remember the trigonometric identity, right? If you give x equal to tan theta, it becomes 1 minus tan square theta by 1 plus tan square theta. This is the identity which is equal to cos 2 theta, right? So by finding out, recognizing the identity, you can do the substitution. So putting x equal to tan theta, that is theta equal to tan inverse of x. So we get sine inverse of 1 minus tan square theta by 1 plus tan square theta. So this is equal to cos theta, cos 2 theta. Okay. But this is sine inverse and here cos. So we have to change this one cos into sine. So how can we write this one? Cos theta equal to sine 90 minus theta. Therefore sine pi by 2 minus 2 theta. Right? So now we can, this is equal to sine inverse of sine will be pi by 2 minus 2 theta. Then what is theta? That is minus 2 tan inverse of x. Now we can differentiate this. So differentiating with respect to x, we get, so y dy by dx equal to pi by 2 is a constant, isn't it? So it becomes 0. So 0 minus 2 is in multiplication of tan inverse of x, so it will remain the same, into tan inverse of x is 1 by 1 plus x square. So the answer is minus 2 by 1 plus x square. So that's all. So this is the end of derivatives of the inverse trigonometric functions. In the next session, we will start with exponential and logarithmic functions. And if you have any queries, you can contact me at this WhatsApp number or you can mail me. Then please, one request is, first of all, you memorize this list of derivatives. Then it is easy for you to do all kind of differentiation. Thank you.